Hi everyone. I'm going to try to make a video. I'm going to try to do this as quickly as I can to cover as many questions I can in one video. So you can speed up the video or slow down the video however you'd like using the YouTube, playback features. But let's dive in. So I want to go over a couple of these problems. Let's start with this one here. So for these questions, you want to use the graph to describe the movement that occurs from 0 to 4 seconds, and then you want to calculate the displacement. So first of all, looking at this graph from 0 to 4, I can see that the graph goes up and then it stays still, or it's flat. So really what that means is the object is moving in the positive direction and then the object stops moving. So that's what I would say for my description. Now for the displacement, what I see is I started at 2 and I ended at 5. So you can see that I started here and I ended here. Another way to write that is that my final position was 5, but my initial position was 2. So if I want to know my displacement, again, this is one of the equations that is in the practice. That's not right. In the practice questions, displacement is final position minus initial position. So I would do 5 minus 2. All right, let's move on to. Actually, let me just finish solving that. So displacement would be 3. And it looks like the position here is in meters, so my units would be 3 meters. Okay, for velocity, for this one, right, because it says calculate the velocity. I'm looking at the position of the object, so I need to know the position, I need to know how the position has changed, and I need to know how much time has passed. It tells us the time. It says from 0 to 10. So I'm looking at this window here from 0 to 10. Right, that's the time frame I'm looking at. And I can see that they go from a position of 0 up to a position of 60. All right, so right off the bat, I mean, one shortcut here is to say, well, my displacement is 60, right? And if you weren't really sure how to calculate that, again, it's final position minus initial position. If I did that, my final position minus my initial position, well, it would be 60 minus 0, so that's just 60. All right, I know my time is 10. All right, so now all I have to do is velocity is displacement divided by time. All right, and that is 60 divided by 10, which ends up being 6. And again, our units here are meters and seconds. So my units for my final answer are meters per second. All right, so let's move on to another problem here. Let's do number 4. So there's a toy car. It rolls from a starting position of 0.6. Let me zoom in a little bit on this. To a final position of 1.5 in 3 seconds. What is the velocity of the car? So we can see a few things here. We know starting position or initial position is 0.6. Final position is 1.5, and my time is 3.0. One thing I always recommend that you do is write down your variables, and then it might be useful to also write down what is the question asking for. All right. From here, I mean, you can look at your list of equations, but there's one equation that relates all these things. There's this equation that says velocity is final position minus initial position divided by time. Okay. So you can see that has the 3 that we have plus this one that we don't know yet. So we can plug in our numbers. Velocity is 1.5 minus 0.6 divided by 3.0. If you enter that into the calculator, one thing you want to watch out for is in the calculator, you could use parentheses here. I would recommend using parentheses, or else the calculator is going to not give you the right answer. Order of operations is important here. I'll quickly show that to you. So we have 1.5 minus 0.6 divided by 3.0. It gives you an answer of 1.3. That's not correct. What it's doing here is it's doing the division first and then the subtraction. That's not what we want. We want to do the subtraction first and then we want to divide by our time. And you'll notice it's a different answer this time. It's 0.3. And that's the correct answer. We want to do the subtraction first in this case, and then do the division. And again, this is a velocity, so it's in meters per second. We'll quickly do number 7. So number 7, there's a track runner, gives us a bunch of numbers, and it's asking for acceleration. So let's see what we know. We know that they accelerate from 0 meters per second to 12 meters per second. So their initial velocity is 0, their final velocity is 12, and they accelerate in 1.5 seconds. And it's asking for what is my acceleration. So I have my variables, and again, there's an equation that relates all these things. If you look at your list of equations, you'll see that there's this equation that says acceleration is final velocity minus initial velocity divided by time. So I just plug in my numbers. I go 12 minus 0 divided by 1.5. And that, again, do your subtraction first and then your division. That comes out to 8 meters per second squared. Okay, that's our units for acceleration, meters per second squared. Okay, all right, quickly moving along here. Number 10, calculate the acceleration of an 84 kilogram box that's being pushed with a force of 54 newtons. Again, so let's write down what we know. I see a force. I see my force is 54 newtons. I see a mass. Kilograms is the units of mass. So I have a mass of 84 kilograms. And I'm being asked for acceleration. So again, hopefully you can kind of see what equation you're supposed to use here. We have FMA, so the equation we want to use is F equals MA. So we know that F is 54, we know that mass is 84, and we're trying to find A. Well, we have 84 times A, and so if I'm trying to get A, I need to get rid of this 84. If I'm multiplying by 84, to get rid of that 84, I need to do the opposite of multiplication, which is division. So I'm going to divide both sides by 84. Now the 84 cancels out on this side, and now I'm just left with A is equal to 54 divided by 84. So we can do that into the calculator. 54 divided by 84. Okay, 0.64. So I could say my acceleration is 0.64 meters per second squared. Again, it's really important for you to show your work and make sure that you label your numbers well and give me the correct units. All right, let's keep moving on. I'll quickly go over 11. So if the force, basically, if the force doubles, what happens to acceleration? So when you're looking at this table, you want to find a situation where the mass is constant. So you kind of want to focus on the bottom part of the graph where mass is constant. I have 60, 60, 60, 60. All right. Now I want to look at a situation or two trials where the mass doubles. I can see that the mass doubles from trial 4 to trial 6. I go from 120 to 240. All right, so I can use these two trials, 4 and 6. And so the question is, when the force doubles, what happens to acceleration? Well, I can see it goes from 2 up to 4, and that's a doubling. So I can say that when force doubles, acceleration also doubles. And I hope that makes sense when you think about our equation of F equals ma. If this number suddenly gets bigger by twice as much, then this number over here should get bigger by twice as much, right? If this relationship is going to hold, if force doubles, then acceleration also doubles. You can imagine that the harder you push on something, the faster it's going to move, right? So the more force, the more acceleration. All right, let's do 2 more, and then I'll stop this video. So number 12, we have a couple of people pulling on a rope. What's the net force? So for force questions, I recommend drawing a diagram. I guess I didn't do that in the last one, but it can be helpful, especially when you have more than one force acting on an object. So in this case, we have a couple of people, and there's a rope All right. And so Angel over here, Angel is pulling with a force of 196 newtons. Brian is pulling with a force of 114 newtons. So I'm going to try to draw their arrows accordingly. This arrow should be bigger because that force is bigger. All right. So what's the net force? Well, net force is all your forces added together. F1 plus F2 plus whatever, however many forces we have. In this case, we only have two forces. We have Angel and Brian. So I'm going to plug in those numbers. So let's say Angel will be force 1. So he's negative 196. It's negative because he's going to the left. All right. Brian, on the other hand, is pulling with a positive force because it's to the right. So I just add those two forces together, and the net force is negative 82 newtons. Okay. All right, and then real quick, let's talk about, I'll quickly talk about 13. So what would happen to the motion of an object if the net force on the object was equal to 0? Well, if you imagine, I don't know, you can imagine a couple things. You can imagine that there's a block here, and we might be pushing it this way, but there might also be the force of friction this way. Well, if those two forces are equal, then the object will not be accelerating, right? So if the net force is 0, then acceleration has to be 0, right? Remember this rule, F equals ma. If the overall force is 0, then this also has to be 0. You could be moving at a constant speed or a constant velocity, but you're not accelerating. You could have forces acting on an object, but the object is not accelerating. I mean, another example is, a block on a table, right? You have gravity pulling it down. You have the normal force pushing back up. You have forces acting on the object, but they're equal and opposite. So there's no acceleration. All right, and then real quick, number 14. I'll quickly just dive right into the answer. I know there's a lot of reading to do, but the major idea is to watch out for the numbers and to watch out for the directions. I mean, even if you get bogged down with all the words, watch out for the numbers and the directions. I mean, the first thing that catches my eye is 185 newtons to the right, and then 195 newtons to the right, and then 276 newtons to the left. I mean, if that's all you read, you could get the answer correct. So we have some object. There's a force this way of 185. There's a force this way of 195. But then there's a negative force of 276 this way. And so the question is, what is the net force? What is the net force? Well, again, same idea as before. Net force is just all my forces added together. So F1 plus F2 plus F3, because I have three forces this time. All right, so I have 185 plus 195 minus 276. Now it's a minus because this is a negative force because it's going to the left. All right, if you add all that up, you get 104 newtons. So that's my net force. Now, what's my acceleration? Well, I need to know the mass, but that's given to us. We have 109 kilograms. So using this rule of force is mass times acceleration, I can plug in my force of 104, I can plug in my mass of 109, and I have my acceleration. And just like we did before, I can divide both sides by 109, divide both sides by the mass, and I'll get my acceleration. My acceleration is going to be 0.95 meters per second squared. All right, so that's the end of my first video. I'll do one more video to go over the problems, and I hope this is all useful to get ready for your final exam.